Hi, my name is Aaron Abadjian, and this is my final poster for cs224d. I first wanted to thank again the TAs and the instructor for answering my questions on Piazza and in person in the TA office hours, and for allowing me to record this video. My project was titled Classifying Responses on Online Discussion Forums. You're probably aware that there's an online discussion forum for almost every topic. If you're if you have a cat, if you're a cat owner, if you have a certain type of car, if you like a certain movie, you can find an online discussion forum where you can ask questions about that topic and get responses from people in the community who also enjoy that topic. The problem with discussion forums is that there's no way to upvote the best answer. Nowadays with Reddit and Stack Overflow, you can upvote, but I'm talking about traditional online discussion forums. People respond and responses are just displayed chronologically. Now, when you ask a question on an online discussion forum, people are free to respond in any way. Taking the very simple example of asking, what color is the sky? An answer would be, the sky is blue. Another answer would be, the sky is pink, or the sky is beige. Now, obviously beige is not a correct answer, but still an attempt at answering. Compare this to a response that says, just Google it, or no idea, good luck, or I don't know, but when you find out, let me know. Those three examples are non-answers. They're not even attempts at answering. The purpose of this project was to distinguish answers or attempts at answering from non-answers. Now, let me start by giving you a couple more examples so the idea is clear in your mind. Right in the center, I put my cost function. And let's look at these four question-response pairs. Question-response pairs are my training data. What color is the sky? The sky is blue. This represents a question-response pair where the response attempts to answer the question. So I assign it a 1-0 label. Sorry. The next one, how do I remove this virus? Response, no idea, good luck. This does not attempt to answer this question, so I give it a 0-1 label. And so on and so forth for these next two examples. A 1-0 represents a response that attempts to answer the question, and a 0-1 represents a response that does not attempt to answer the question. So that my cost function is simply maximizing the number of correctly classified responses. Responses that are non-answers classified as non-answers, responses that are answers classified as answers. To get these question-response pairs, I had to build a crawler and a parser for an online discussion forums. And I made a very generic one that was able to download 59,000 question-response pairs from 10 different online forums. And then I used Amazon Mechanical Turk to have real people hand-label these question-response pairs as either answers, a 1, or non-answers, a 0. And then I parse it into these correct labeled vectors. I ended up with 27,682 question-response pairs, and I split it into 80% of a training set, 10% of development set, and a 10% test set. Now, to give you an idea of how the model works, I started this project quite some time ago, and it's largely based upon the recurrent neural network from homework 2. The network reads the question-response pair sequentially. So it goes, what color is the sky? The sky is blue, starting with this XML style Q token and ending with this closing XML R token. The overall probability of a response answering a question within a single statement, within a question-response pair, is given by a softmax, where the first component of the softmax represents the probability of an answer, and the second component of the softmax represents a probability of a non-answer. Now, the softmax is applied to this U matrix times an H function that's defined recursively as follows. And again, this is very reminiscent of homework 2. Sigmoid of H matrix times the previous little h plus the index into the word vector matrix given by x sub t, which is the index into the matrix, the next word that we see. And so thus the model learns the word weights along with the weighting matrices H and U. Now I played around with several parameters that I describe a little bit more in the paper, including what was the best T max, the number of back steps to consider, recursive steps to consider, whether or not a gating window would help, a memory window would help. But those are described a little bit more in the paper. Overall, I was able to achieve a 76.3% classification accuracy, meaning the model was able to distinguish non-answers from answers based upon the mechanical Turk labeling 76.3% of the time. Now, this model I compared it is an extension of some work that I did for cs221. And in that class, I built a support vector and a logistic regression classifier applied to the same task. Those models did very well. They were able to get up to 89% classification accuracy on the same data. And the reality was that I was able to design handcrafted features that I couldn't feed into this model as is. Some of those features were very interesting, such as who is the author of the post. The original poster is very unlikely to answer his or her own question. So if the original poster is responding, usually they're responding with something like, "Thanks for all your help," or "I guess no one can help me, so I'm leaving now." So basically, usually the original poster, when he or she responds to his own question, is not giving an answer. Another interesting feature that came out from the logistic regression work was, is a response quoting another response? So if I answer a question on a forum, and then someone else quotes me and says "thanks" right underneath it, well, that quote is giving a very strong feature that I said something that is an actual answer. And so those are some of the novel features that I was able to encode in the SVM and logistic regression classifiers that was able to get the fit really high. The beauty, or maybe simplicity, of the RNN is that I believe I can get a higher performance if I just feed it more data. But I need to validate that concern. I kind of ran out of time at this point. But I want to continue with this work, and hopefully I'll make some more progress down the road. Now, lastly, I'd like to close with a practical example. What is the utility of such a thing? Now, here's an actual question from an online forum. My Apple TV will not connect to Wi-Fi. Having put in the passcode, it displays connection error -3905. Can anyone help? The RNN scores these responses at, again, do they attempt to answer the question? In its point of view, really none of them attempt to answer the question, which is not correct. We can see that this fourth answer really does try to answer the question, and that the first one and the third one are also attempts at answering. The second one is really someone else just also agreeing that they have the same problem. If we look at the logistic regression scores, we see that the LR classifier really assigns a positive greater than 0.5 probability that these are answers to the ones that we think would be answers. Okay, this one's really close to being an answer, but it's right on the threshold, 0.482. But the idea is, if you can distinguish which responses are likely to be answers from those that are not likely to be answers, well, you could reorder these responses based upon how likely they are to be answers. Again, I'm not saying that they're the best answer. It's just we're putting non-answers like "I have no idea" or "Google it" or "bump," etc. at the very bottom. And so that's the project. Again, it's still really a work in progress, as I actually put together a search engine that's based upon this data. You can visit gotoanswer.com, and that search engine is still based upon the logistic regression classifier. But if I can improve the performance of this classifier, I'll switch it over. But overall, it was pretty exciting work learning about neural networks. I had some difficulties in the beginning, but I think I have a strong grasp of them now. And overall, I think it was an enjoyable class. Thanks for your time.